Okay, Assalamualaikum and good morning. So we continue our class on the tutorial of reciprocating pumps. So we go for question number 1. So let's say we have a single acting reciprocating pumps. So the piston diameter is 150 millimeters. The stroke length is 300 millimeters. The rotational speed is 50 RPM and the water is to be raised through 18 meters. So determine theoretical discharge, and then if the actual discharge is 4 liter per second, determine volumetric efficiency, slip, and actual power required, and take the mechanical efficiency as 80%. So this is the very simple question for reciprocating pump. So it starts with the calculation of the flow rate. So because we know that we it is a single acting reciprocating pump. So the flow rate can be calculated by using this equation. So you substitute all the values here. So you will get the flow rate is 4.41 at 5 liter per second. So at this stage, I hope you know how to convert the meter cube per second with liter. So it is 1,000 liter for every 1 meter cube. So and then we could calculate the volumetric efficiency. So the idea of efficiency is power out divided by power in. So and the volumetric means we need to calculate whether the actual volume of water equal or not with the theoretical. So means that the actual volume cannot be more compared with the theoretical. So the symbol of eta here, I think you already know because we use the symbol of eta as efficiency in fluid mechanics 1 and 2. So the volumetric efficiency is the actual discharge divided by the theoretical discharge, and then the actual is given in the question as 4 liter per second. And the theoretical is 4.41 at 5 times 100%, so you will get it is 90.53%. And then to calculate the slip, so we have this equation. So we substitute with the value, so we get it is around 9.47. So it is good for you to know this as 9.47%, because this number and this number actually must be equal to 100%. So you could imagine that the slip is actually to represent how many flow rate loss when piston push that volume to deliver it. So and then the volume efficiency is show us the percentage of how many percent is actually can be in the piston. So actually if you sum of these two value, you need 100%. So it is better for you to write as 9.47 only. So and then power required. So you know that power is rho GQH. So we could calculate the power as 706.32 watt. So it is depend on our requirement. We need to the actual flow rate is 4 liter per second, and we need to transfer that water as 18 millimeter high. So and then we substitute all the values, we get the 706 watt. But we must know that piston pump has only 80% in mechanical efficiency. So normally in piston pump, we are talking about mechanical efficiency because we don't have any manometric efficiency. We have only the volumetric efficiency and also the mechanical efficiency. So the mechanical efficiency will represent how good your mechanical parts transfer energy from the crank to the piston and to the until the water reach the output tank. So the eta here, the mechanical efficiency is equal to 80%, so equal to 0.8. So and then the power of efficiency is power out divided by power in. So power out is actually power that we need to transfer water until 18 meters. So it is 706. So and then you could substitute in this equation, rearrange, and then we could get that power required, power that we need to supply to the pump. It is around 882.9 watt. So means you need to imagine that we need to supply 882 watt, because 706 watt will be used to transfer water until 18 meters high, and the last 20% will be used to overcome friction and so on. So this is example 2. So in here, so we have a single acting reciprocating pump, has a plunger diameter of 125 meter and a stroke of 300 meters. The length of suction pipe is 10 meter and diameter is 75 millimeters. Find acceleration head at the beginning, at the middle, and at the end of suction stroke. If the suction head is 3 meter, determine the pressure head in the cylinder at the beginning of stroke. At the beginning of stroke, when the pump runs at 30 RPM, take the atmosphere head as 10.23 meter of water. So reciprocating pump has a plunger. So plunger is some kind of piston actually. So it just used to push water to the delivery pipe. So here I think you already know. I already explained that the velocity keep changing, and then it create acceleration. Then acceleration is also changed because the angle, the theta is different. So we have the beginning, middle, and end of suction. So and then it gives you the atmospheric head here, which is equal to 10.23 meter of water. So I think you already know about this. Previously, we could, you know that PATM, so it is equal to 101.325 Pascal. And then if you convert it into rho, water, G, and H, and then you will find H is equal, is around 10.23 meters. So I think you still, I hope you could, you still remember this calculation to represent the atmospheric pressure in terms of height of water. So means so and then first we need to calculate the acceleration head at suction side. So this is the equation. So and then we prepare the details. The suction length is 10 meter. So this is the cross-section area for piston, and this is cross-section area for suction pipe. So and then this is the value of omega, and this is the value of R. So as I explained previously, R is the radius of the rotational device, okay, to move the piston, and it is equal to stroke divided by 2. So we have a 300 millimeters stroke. So it is equal to 150 millimeters, which is 0.15 meters. Okay. So and then we substitute all the value here. So we found that so we could get it is equal to 4.193 cos omega t. So omega t is the variable that can be substituted because we have three conditions, which is the beginning, middle, and the end of suction. So here the beginning, middle, and end means that you need to understand the movement of the piston. So suction means piston needs to start from here to here. So means that this at the beginning means at this location, middle is at the middle, and the end of the suction should be here. So and then in the next question, maybe you have a condition with the delivery stage. So in delivery stage, so here will become the beginning of the delivery. So here will become the middle, and this is the end of the delivery motion. So I hope you could understand the motion of piston pump here. So what we need to do at the beginning, we assume that the angle is 0 because the crank arm here is actually at the 0. So and then the cos 0 will give us 1. So we have the head acceleration is equal to 4.193. At the middle, so we have 0 because the value of cos theta is 0, and at the end, so we have negative 4.193 because the cos theta value is minus 1. So I think I hope you can understand this. So and then we calculate the pressure head inside the cylinder. So this is very important. Why? Because for suction, I think you could imagine we need to create a vacuum condition before we could suck water from the inlet tank to the piston. If we cannot create that, means we cannot overcome the atmospheric pressure. So for example, in this diagram, so the pressure atmospheric here is push the surface of water. So okay, you can imagine this one. We learned this in fluid mechanics 1 and 2. So and then if the piston move to the right here, so we hope that the volume created inside this cylinder is lower than atmospheric pressure. So why? Because if this pressure here is lower than the atmospheric pressure, so now atmospheric pressure will push water here and it could flow to the cylinder. Okay, in simple terms, so we need to create a vacuum so water can be sucked to the cylinder. So then the calculation of pressure head in the cylinder is given by this equation. Okay, first you need to understand the nature of that motion, means the nature of that application. So we need to create a vacuum. So that's why we start with the atmospheric pressure, because this is the pressure who push the water surface. So at the beginning, pressure at this area is also atmospheric pressure, and the pressure here is atmospheric pressure too. So means the pressure is now balanced. That's why the surface of water is remain at this level. Okay. So to create vacuum means, so from the atmospheric pressure, atmospheric head, so we divide by the head suction head, and we minus with the subtract with the suction head, and then we subtract with the acceleration head. So why we need to subtract with suction head? Because okay, we need to overcome the suction high here. So at least we need to create a vacuum to make sure that water could travel for this high first. So kita kena pastikan air boleh diangkat melepasi ketinggian suction head, kemudian barulah kita fikir untuk memastikan air untuk masuk pula ke dalam silinder. So kita masuk ke dalam silinder, kita represent sebagai acceleration head. So antara physical meaning berkenaan dengan acceleration head ialah kita kena overcome kelajuan piston yang bergerak. Kalau kita tak boleh nak follow kelajuan piston, air pun tak boleh nak masuk. So contohnya dalam picadari, kalau awak tarik laju-laju, kita kata air tak masuk pun. Kerana apa? Air tak sempat nak overcome dengan pecutan ataupun pergerakan piston. So that's why we deduct the value of atmospheric pressure here, atmospheric head here with the suction head and the acceleration head. So we have 10.23 minus 3 and minus 4.193. So we get it is around 3.037 absolute, okay, head. So in piston pump, we always use absolute pressure. Why? Because we need to create vacuum. That's it, designed. Okay, so this is the most practical one, because it is okay for us to use gauge pressure. Means we assume that atmospheric pressure is equal to 0, but it will give you a negative sign. So it is not easy to talk when the negative, because when you forget to write your negative sign, so the value is totally different. So engineers will use in absolute pressure to make sure that we could reduce the possibility to the problem with the negative sign. Okay, so this is the calculation of the pressure head in cylinder at the beginning. So in this question, we just focus on the beginning because this is the very important stage. Because at the beginning, we must create the lowest pressure compare with the middle and the at the end. So di peringkat awal lah kita perlu memastikan piston pump kita memberi tekanan vacuum yang cukup tinggi, membolehkan air untuk naik.